For 10.7b, we're doing more proof by induction, but more specifically, we're going to focus on divisibility proofs today. Okay, so we went through the steps in the last lesson. Step one involves plugging in 1 and showing that it's true. So step 1, when n equals 1, what do we get? We get 7 to the first minus 1. This equals 6. And because 6 is divisible by 6, the statement is true when n equals 1. Okay, step 2 just involves stating an assumption. So we will assume seven to the power of k minus 1 is divisible by 6. Alright, I want to clarify that statement because it'll make step 3 easier. So what we really mean, so let's actually talk about what does it mean for a number to be divisible by another number. So to be divisible by 6, what that means is the number has to equal 6 times some other integer, or in this case, some other natural number. So we're going to say that 7 to the k minus 1 equals 6 times r, and then we have to clarify that not only k is a natural number, but so is r. So k and r are both elements of the natural numbers. So technically, to be divisible by a number, it just has to be that number times another integer. Now, I called it a natural number because if we're plugging in a natural number for k, then 7k, or 7 to the k minus 1 is going to be positive. So I know that r is going to be positive as well. So instead of saying integer, I said natural number. Okay, step 3. This is where you show I'm not going to say equation today because it's not an equation, it's a statement. Show statement works for n equals k plus 1. Okay, so what we're trying to show is that 7 to the k plus 1 power minus 1, we want this to be divisible by 6. So what I'm going to do with the 7 to the k plus 1, I'm going to change this into 7 to the k times 7 to the first. Okay, and now using this equation, if I move the -1 to the other side, I know that 7 to the k equals 6r plus 1. So what I'm going to do now is replace 7 to the k with 6r plus 1. And I got that from step 2. 7 to the k equals 6r plus 1. And multiply that by 7 to the first, or just 7. So if I distribute the 7, I get 42r plus 7 minus 1 equals 42r plus 6. We're trying to show that this expression is divisible by 6, so we should factor out a 6. Okay, and that pretty much proves it. So we can say that since r is a natural number, 7r plus 1 is also a natural number. Okay, thus 6 times 7r plus 1 is divisible by 6. And what were we trying to prove? We were trying to prove that 7 to the k plus 1 minus 1 is divisible by 6. Okay, and that concludes our proof. So let's put a symbol to specify that we're done. Okay, let's try another. So step 1, when n equals 1, 6 to the first power minus 1 equals 5. Since 5 is divisible by 5, the statement is true for n equals 1. Okay, step 2. We're going to assume that 6 to the k minus 1 is divisible by 5. And let's clarify what that means. It'll make it easier for step 3 to be done. So what does it mean to be divisible? It means that, well, to be divisible by 5, it means that it equals 5 times r. And we need to specify that r is a natural number and k as well. So where k and r are both natural numbers, Okay, step 3, we need to show that the statement is true for n equals k plus 1. Okay, so what we're trying to show is that 6 to the power of k plus 1 minus 1 is divisible by 5. So let's break it up like we did in the last problem. 6 to the k plus 1 is the same as 6 to the k times 6 to the first. I'm just going to write 6. So 6 to the k is the same, 6 to the k plus 1 is the same as 6 to the k times 6 to the first. Alright, now from step 2, we know that 6 to the k minus 1 equals 5r, which means that 6 to the k is equal to 5r plus 1. So I used this equation. I solved for 6 to the k, which is 5r plus 1, and I replaced the 6 to the k in step 3. Okay, distributing the 6, we get 30r plus 6 minus 1, which is 30r plus 5. We're trying to show that this is divisible by 5. So we should take out a 5. So 5 times 6r plus 1. Okay, and we're pretty much done. Since r is a natural number, 6r plus 1 is a natural number. Okay. I'm going to use hence. Hence 5 times 6r plus 1 is divisible by 5. Therefore, and what were we trying to prove? We were trying to prove that 6 to the k plus 1 minus 1 is divisible by 5. Alright, and then we're going to work on disproving things by counterexample. So this is a lot quicker than a proof by induction. So if you want to disprove a statement, you have to just find one example when it doesn't work. When you want to prove a statement, you have to show that it always works, which takes longer. So to disprove, you just have to find one example where it doesn't work. So looking at this statement, 2n squared plus 2n plus 3, does that equal 2 to the n plus 2 minus 1 all the time? So I just like to plug in simple numbers. Let's plug in 1. If I plug in 1, I get 2 plus 2 plus 3. I get 7 on the left. I get 7 on the right, so 1 isn't a good counterexample. Let's try 2. If I plug in 2, I get 8 plus 4 plus 3, so I get 15 on the left. And on the right, we would get 15 again. So 2 doesn't work. Let's try 3 now. If we plug in 3, we get 18 plus 6 plus 3. We get 27 on the left. And we get 31 on the right. So I think 3 is a good number to be our counterexample. So all you have to do here is write n equals 3. And I want you guys to show work as well. So let's plug in. If you plug in n equals 3, you get 18 plus 6 plus 3 equals 2 to the 5th minus 1. So you get 27 equals 32 minus 1, 31, which doesn't work. Okay, number 4. So let's plug in 1. If we plug in 1 on the right side, we get 100. If I plug in 1 here, I get 100, so 1's not a good counterexample. If I plug in 2, where the arrow is, I would get 110. So the left side would be 100 plus 110 is 210. And on the right, it would be, looks like 115. So n equals 2 is a good counterexample. Alright, so on the left side, it's going to be all of these numbers added up until you get to what this would equal when you plug in n. So when we plug in n, which is 2 there, we get 110. So we know this sequence is going to stop at 110. Plugging in 2, I get 4 for n squared. 210 does not equal 115. So n equals 2 is a counterexample. Okay, 2n plus 1 is a prime number. And you don't always have to start from 1. Let's do a big number. Let's just try n equals 10. Alright, so when n equals 10, we get 2 times 10 plus 1 equals 21. 21 is divisible by 3 and 7. So we just disproved that statement.